Okay, we're going to learn how to find zeros of polynomial functions. So we looked at how synthetic division works, and in those examples I give you a zero to try out, and what I mean by zero is that the remainder is zero. If you work through your synthetic division process and you get a zero in the remainder at the end of that process, that means that you successfully have found a zero. Now we're going to get into problems where I'm not going to give you a zero. You're going to have to just find it yourself. So first we need to use this tool I'm about to show you, this little formula, to find the possible zeros. And then we need to test and see which one of those are actually a zero. And this is called the rational zero theorem. And so it's a pretty simple formula, and it just takes an example to get going, and let's show you now. So it's going to be pretty long because there's just a bunch of words, but it's a simple formula. So we say possible rational zeros. All right, and I'm not going to write this out every time, so you'll see me write it as PRZ from now on. PRZ. And this is equal to, we're going to have a big division sign here, and I'm just going to write some words up here and words below here. So the way you find the possible rational zeros, so on the top, it's the factors of the constant term factors of the constant term, the one without variables attached to it. And then on the bottom, it's the factors of the leading coefficient. Factors of LC. So the factors of the constant term divided by the factors of the leading coefficient. All right, and the best way to go about this is to show an example. So we'll do that now. Example 1. Kick the trash can there. List all possible rational zeros of, and let's say we have this function f of x equals negative 2x to the fourth plus 3x squared plus 4. And so now we just use this PRZ formula here. I'm going to leave it written there so we can kind of use it. So PRZ, which is your possible rational zeros, PRZ is equal to, and then we're going to have this big division. So we're going to have a bunch of numbers written on the top and the bottom. Okay, so on the top, we want to find the factors of the constant term. So we come over here and determine what is our constant. It's 4. It's the one with no variables attached. So what I want to do is I want to know all the numbers that, I want to find all the factors of 4. So you can do a little side work, but you won't necessarily have, you don't have to do this work. This is pretty easy in your head. Just to show you where all the numbers come from, things to multiply to give me 4 are 1 and 4, 2 and 2, and 4 and 1. So that's it. Those are the only possible numbers. So 2 is repeated here, so I don't need to write it a second time. So we'll just cross it out. So my only factors are 1, 2, and 4. Now, the trick here is we have to account for the plus and the minus because you could have -1 times -4, which is still +4. So the way you do that is you say plus or minus 1, which is, I get the 1 from here, and now I have 2, so, and then I write a comma, plus or minus 2, comma, and then the last one is 4, plus or minus 4. So that gives me all possible combinations to multiply to give me 4. And they need to be integers, obviously. Now on the bottom, we find the factors of the leading coefficient. Remember, the leading coefficient is the coefficient that's attached to the degree, the highest exponent. So 4 is my degree, and -2 is what is attached to it. So don't worry about the negative in there because we're going to account for the plus and the minus anyways. So now we just need to figure out the factors of 2. You can write it out like I did here, but you should be able to get to the point where you can just write this down. And this one's easy. It's only 1 and 2. So plus or minus 1, plus or minus 2. And so now, I'm going to erase this bottom part. We have all that set up now. And from here, it's just being careful. That's all it is. Being careful that we account for all possible combinations on the top and the bottom. So the easiest way to do it is just start with your first term on the top, which is this plus or minus 1. You take this plus or minus 1 and you divide it by each term on the bottom. So you go plus or minus 1 divided by plus or minus 1. Plus or minus 1 divided by plus or minus 2. And then we'll move on to the 2. 2 divided by 1 and then 2 divided by 2. So let's write it out. Let's start with here, the 1. So plus or minus 1 on top divided by plus or minus 1. And I'm still on plus or minus 1 on the top, so I write a comma, plus or minus 1 divided by plus or minus 2. So this term is divided by each one on the bottom. Now we move to the next term, which is this plus or minus 2, and it gets divided by each term on the bottom. Comma, plus or minus 2 divided by plus or minus 1. Comma, plus or minus 2 divided by plus or minus 2. So just double check, this 2 was divided by the 1 and this 2 was divided by the 2. And that's what I have here. And then we move on to the next term on top, 4. 4 needs to be divided by 1 and 2. So 4 divided by 1, so plus or minus 4 divided by plus or minus 1. And then plus or minus 4 divided by plus or minus 2. All right, now we can go ahead and simplify. So 1 divided by 1 is 1, 2 divided by 1 is 2, and so on. And we're not going to have to write these plus or minuses twice. You only need to write them once. So we can say plus or minus, because we only need to write it once, and then we do the division. 1 divided by 1 is 1. And then we're going to have plus or minus, and this is 1/2. So we just leave it as 1 over 2. And then plus or minus, 2 divided by 1 is 2. And then plus or minus 2 divided by 2, which is 1. And then 4 divided by 1 is 4. And then 4 divided by 2 is 2. A little crooked there. So you see that some of these are repeating, and so you want to get rid of those. Especially in the homework, if they ask for it, you're going to want to get rid of the duplicates, and I'm not sure, sometimes the online homework can be tricky. They might want it in numerical order. So if you input the wrong answer, just try again and put them in numerical order. So I'm going to come up here and mark out the duplicate. So here's 1. 1 repeats right there. And then I have a half. There's only one of those. And then 2. 2 is repeated right there. So there are my answers. So you get plus or minus 1, comma, plus or minus 1/2, comma, plus or minus 2, comma, plus or minus 4. And these, there are 8 numbers here. You have 1, the plus or minus of 1, plus or minus of 1/2, 2, and 4. So you have to count for the plus and minus of each of these. So these are our possible rational zeros. And so these are the numbers that we would plug into our box in synthetic division, run through our synthetic division, and if we get a 0 in the remainder, that means that that possible rational zero is a 0. And then we'll continue on, continue working it to find all the other zeros. But to find all the other zeros, we just don't plug in all 8 of these to find the however many zeros there are. We want to go through the same process we did earlier, and in the next video I'm going to go over that.